Okay, better lighting for this video. So calculate the standard enthalpy change for the reaction delta H in kilojoules per mole using the thermodynamic data in section 12 of the data booklet. So get the data booklet out, have a look what data you've actually got. They are giving you some information, so the formation of ozone is plus 142.3 kilojoules per mole. And then all of the other pieces of information you get from the data booklet. Use your equation, the one that you just constructed here, to support you in this. Now I'm going to tell you what the IB mark scheme says, and then I'm going to tell you what I think, and the two don't agree, so you can see what your thoughts are on this. The IB is stating that this is the answer, 660.8. I disagree. I've done it a few times and I still disagree. So these are my calculations. We're looking at formation. It's given us the enthalpy of formation of ozone. We've written out my equation at the top. This is a piece of information that's given to me at the top here, so the 142.3. I've got two of them, so I'm multiplying it by 2. I'm making sure that I represent the sign is positive because it's indicated as a positive there. Formation is when you have a molecule and it's formed from elements in their standard states. So oxygen, hydrogen and carbon, formation of ozone. Then we need to look at what else we've got. Okay, so we've got water being formed, we've got carbon dioxide being formed, and we've got methane being formed. Oxygen is an element, so it's not being formed from itself. Put all the numbers in from the data booklet, from the data booklet, from the data booklet, from the question. Really sneaky thing, I almost missed it myself. There's two values in the data booklet for water. One's for steam, one's for water. Combustion produces a gas. This is steam. So the number is 241.8 times 2 rather than the other value that's in there. I think it was 280 or something similar to that. So multiply that by 2 because there's two waters, or steams, and the other numbers are left as they are. Now the way that we've looked at it before is the answer is independent of the route taken. So as you go from here to here, it will match as if you're going from here to here. So if we've got if we're trying to calculate this, and we've got all of these pieces of information, we can put the pieces of the puzzle together to make it match. So to get from here to here, we'd have to go down to here and then up to here. So all of these arrows match the direction of my arrow, so the numbers all remain the same with the same signs. For this one, however, I'm coming in the opposite direction, so I change my sign to become a positive. So I've got positive 74 because I'm going in that direction, plus minus the 393, 2 lots of the minus 241, and 2 lots of the minus positive 142.3. If you do that and you add it all together, you get minus 518.5. I've done this several times. That's the answer that I keep getting. The answer that the IB gets doesn't even match the statement. So this is the statement that they quote. If I do that statement, I get this value here. But if I do this statement and I minus the 74 rather than adding the 74, minus a minus, then I do get 660. So I disagree with this, but if you disagree with me, do let me know. State why the standard enthalpy change of formation for oxygen is not given, because you're forming it from its elements in their standard states, and oxygen is oxygen in its standard state, so it can't be formed, therefore it is going to be 0. Next question is asking you about bonding in oxygen and ozone. Draw them. Don't think you remember them. Draw them. Draw the Lewis structures. Check that you know what you've got going on, because a lot of you made some silly mistakes here. So oxygen, O2, is a double bond, 1 mark. Ozone is a resonance structure, so it's a resonance hybrid. It has somewhere between 1 and 2 in terms of its bonds, so we say it's got a bond order of 1.5. 2 is more than 1.5, therefore oxygen is stronger, therefore needs more energy, therefore the answer is I. And you have to be careful, because quite a few of you didn't actually talk about this, you just referred to the bonding. Okay, so make sure you do give the answer. Another ozone question. They really like ozone. So dichlorofluoromethane, as an example, outline the reactions for depletion. Quite a few of you have looked at how ozone is formed rather than how ozone is depleted. Formulate an equation for the steps in the process and explain the initial step, just the initial step, by reference to the bonds. So the initial step is when you've got your chlorofluorocarbon, you apply UV light and it splits into radicals. So a Cl radical and a CClF2 radical, 1 mark. Why does it do that? Why doesn't the fluorine come off? Because the chlorine bond to the carbon is weaker than the fluorine bond, so it's easier to break. So that would get you the 2nd mark. And then you've got 3 marks that come from just showing how the chlorine radical can interact with the ozone and how it can alter the structures. So, chlorine radical can react with ozone to form a ClO radical and oxygen. Then if you remember, I said bring it down. The ClO radical can react with ozone to form a chlorine radical and 2 lots of oxygen, another mark. And then the one that most of you didn't get, and I've got to be honest, it is one that I would have missed out. It's quite sneaky. They are expecting you to also put an alternative propagation step. So if the ClO radical were instead to react with an oxygen radical, then you can form oxygen and a chlorine radical. So you also would get a mark for stating this one. Again, I think that's a bit sneaky, but I don't write the exams, so we have to pay attention to it. Now the dots, you can draw with dots, you can do it without dots, but you have to be consistent. If you put a dot here and then you didn't put here, they wouldn't give you the mark. If you put dots in this one and then missed dots from this one, they wouldn't give you the mark because it wouldn't be clear that you understood what was actually going on. I prefer it that you do use dots because it shows you what's happening and you can see the order, but again, I'm not going to be the IB examiner, so it's totally up to you.